Hey, this is Dr. Kraus with another Intro to PLC video talking about one-shot instructions, a confusing name for a simple concept. I just made that up. Okay, so what is a one-shot instruction? Again, it's kind of a weird name. What I remember reading about this is that it's kind of a weird explanation with a hammer, bullet, and trigger. Not everyone loves a firearms analogy. We're going to try not to focus on that. The key assumption that I don't know if it was fully explained to me, or maybe it was just I was supposed to know this when I was reading the hammer bullet trigger analogy, is that you don't have an automatic weapon. The idea being you pull the trigger, you get one shot, and then holding the trigger doesn't actually do anything. So again, I think that's where the name comes from, maybe. I appreciate that it's a weird analogy. It's really not that hard if you think of it from a signals standpoint. And so, and I'm going to get to this later in this presentation, maybe it's easier to think of it as an edge detector. So if I have some signal, whether this is from a sensor or a push button or something, when I first flip it on, we call this a rising edge. It's an edge that's going up as the signal goes from 0 to 1 or from 0 to 24 volts. This is like a conceptual one, like a 0 could be false and a 1 would be true. This could be 5 or 24 volts or something else. What we're saying is if I'm just looking at the voltage of input 0, for example, when I push this button, it would stay on. But the one shot is only going to be true on that rising edge. Now, the thing to make it even more confusing and why I don't love the name one shot is it's not truly one shot. It means one shot per button press or one shot per trigger pull. But if you release the button and push it again, every time you have a rising edge, you will have another time that the one shot is outputting a true value or fires. So maybe it's helpful to, instead of calling it a one shot, calling it an edge detector, or to be really specific, a rising edge detector. Now that being said, in the PLC industry, people know this name and nobody really knows this name, which would be abbreviated RED, which might be good or bad. So I'm not completely serious about that, but know that it really, this is the picture to have in your head, or maybe this. Go back and forth really fast until it melts into your brain. Rising edge is true. Staying on doesn't do anything. Okay, let me demo this on my PLC computer. So in this demo, I want to show that a one-shot is an edge detector. It'll be true on every rising edge, but only on the rising edge. It does not stay true the entire time that the input is true. But it is also technically not a one-shot in that if you go back low, it'll be true again on the next rising edge and on as many rising edges as there are. So this is my full program, with the input buffering JSR in the top rung, the output buffering JSR in the bottom rung. I'm going to zoom in just so it's easier to see, but know that those two things are there. So what I've done to illustrate this is I've created two variables, one called loop count and one called edge count. And note that I'm using add blocks and not counters because counters already only respond to edges. We're trying to illustrate the opposite here. So when I flip this on, the loop count starts going up for as many times as we pass through the loop, but the edge count only responded to that first edge. Then if I go back low, both stop. When I go back high, loop count turns itself back on and it's just adding up every time. I've now passed through the loop 200,000 times because it's pretty fast, but I've only had two edges. So this on switch is the whole thing. Loop count is counting every time I passed through a loop and it was high, but the one shot is only responding to that rising edge. Anytime you had an application where you needed to detect a rising edge and only respond to that, then an ONS would be helpful. Yeah, hopefully that makes more sense. Let me know if you've got questions. Thanks.